Welcome, everyone. It's good to see you here. We shall get starting with this event we have today. A few people will still be arriving. I'm happy to see so many of you already here. My name is Sakari Säynäjoki. I'm one of the organizers of this event today. We have Jean-Baptiste Fressoz to give us a lecture today on his latest book. Before that, here's the program. You figured probably we're in the first point. After this, I will let Jean-Baptiste loose. He will speak for about an hour on his book, after which we will have an interview with my colleague, Professor Mihiru Nagatsu, here on stage. So we took the right to ourselves to reserve the first questions. After this, we will have time for some audience questions. My colleague Toni Ruuska will be running around with a mic, and I emphasize that please, if you have a question, do speak into the mic, otherwise the stream won't hear you, and probably neither will we. After all of this, we have a small reception here in Tiedekulma with some refreshments. But first, a few words about our guest, Jean-Baptiste. He is a historian of science, technology, and the environment, and he is based in the French National Center for Scientific Research. He is a research director there, and also a professor at ENPC, the name of which I shall not butcher here. You can read it yourself. He is author of multiple influential books and numerous scientific articles, which have had a profound scientific and public impact on multiple fields of research. His books include The Shock of the Anthropocene with Christophe Bonnieux, translated in 2016, Happy Apocalypse, translated in 2024, Chaos in the Heavens with Fabienne Lochar in 2024 as well, keep him busy, and more and more and more, the one we'll be hearing about today, also 2024. So it was a busy year, I'm sure. Now, I could preach to you quite a bit about these books. I could even say that I am a fan of them, as I'm sure some of you are as well, but I'll save all of that. Still, I just have to note that in his work, there is a common thread that one can find from all of these books. Fressoz's critical histories have dismantled many received and commonly accepted truths about technological and environmental history. Just to name two examples, this is a sentence that many accept. We ended up with the current eco-catastrophe because people didn't know what they were doing. The story of a sudden awakening. Well, instead of this, Fressoz has shown that we have had a long history of political struggles and intentional disinhibitions towards technological and environmental risks. Another sentence could be, we have had many energy transitions before, now we just need another one. Well, Fressoz has shown that instead of this, it was more like more and more and more. I will let him elaborate on that. A little bit on this book itself. Upon its publication in 2024, it became an instant international bestseller. It received the French Senate History Prize. It was named the Book of the Year by The Economist and Financial Times, just to name a few of the prizes it has received. Shortly put, it has transformed the received wisdom on energy transitions. Now, Fressoz will tell you a little bit more about that in his lecture. So please join me in welcoming Jean-Baptiste Fressoz on stage.
Okay, first of all, thanks a lot, Sakari and Mihiru, for this invitation. It's a true honor to be here today. My book is questioning the use of history in contemporary debates. If you pay attention to that, you see that history is very often invoked to predict and talk about the future. Very often, you can hear politicians explaining that what we need to do facing climate change is a new industrial revolution, that the energy transition is a new industrial revolution. When they say this kind of thing, it means that they have in mind a very false history of energy. They do believe that in the past, there have been energy transitions, and now we have to make another one. They have in mind the idea that the Industrial Revolution was a kind of energy transition from wood to coal, right? Of course, this is a false history, as most of you know here. What is even stranger is that you also have this false history in the experts' reports. If you look at the last IPCC report, the report of the Working Group 3 of the IPCC, you can find these very strange sentences. Energy transitions can occur faster than in the past, or a low-carbon energy transition needs to occur faster than previous transitions, right? But once again, as you all know, these past transitions are somewhat mysterious, right? We are burning more and more coal each year. We are burning more and more oil, more and more gas, and also more and more wood. Wood energy today, which will not surprise you in Finland, actually wood energy is much bigger than nuclear energy on the global scale. If my colleagues from the IPCC Group 3 can talk about past energy transitions, it's because they willingly or unwillingly confuse the dynamics of technology with the dynamics of energy and materials. They project onto energy and materials this kind of very simple substitution curves. They use a very classic tool, which is the S-curve, the diffusion curve, which maps the diffusion of innovations. And for them, energy transition is a new technology replacing old technology. This is a graph from the IPCC Group 3 last report. But you can't do that. I mean, if you look at energies and materials, the story is very different. It is purely cumulative. What I've just told you about energy is true for almost all raw materials. It's not just coal, oil, gas, which is growing. It's almost every raw material. There are very few exceptions to this rule. One is ship wool. Ship wool has decreased by a third since the 1990s because of the competition with synthetic fibers. And it is not a good news for the environment. The only examples of raw materials where we had a sudden decrease are asbestos and mercury. So change is possible, but we have to act. We cannot rely on coal, gas, oil becoming obsolete. In a way, you can summarize the history of materials in one sentence: raw materials are never obsolete. Technologies do become obsolete, but raw materials are never obsolete. Despite all the innovations that we had in the 20th century, raw materials have not decreased. On the contrary, they have increased. So this is really a very basic point, but I think we need to keep that in mind when we hear about innovation solving this or that environmental problems. Despite all the innovations we had in the 20th century, especially in organic chemistry, raw materials have not decreased. If the IPCC experts can talk about past energy transitions, it is also the fault of historians. Historians have been very keen in talking about energy transitions. In a way, energy transition is the main topic of the history of energy. If you take the main books on history of energy, the focus is really on shifts, on energy transitions. Just consider the table of contents of these books. Most of the time, they will talk about wood energy and hydraulic energy in the 18th century, in pre-industrial times. The chapters on the 19th century will be mainly dealing about coal and the steam engine. And the chapters on the 20th century, most often they are about oil, a little bit about atomic energy, very little about gas. But of course, this is a very peculiar way of telling the history of energy. Actually, 95% of coal was extracted after 1900. And over 50% was extracted in the 21st century. So really, the great age of coal is right now. It's not the 19th century. Despite this obvious fact, most of the historiography is about coal in the 19th century in Europe, whereas the major part of history of coal is actually Asia in the late 20th century. If historians talk about energy transition in the past, it's because what they have studied are the relative shares of energy, the share of wood, the share of coal, the share of oil in certain energy mix. This is an important graph from a classic book in history of energy. When you see this graph, of course, it gives the impression that there is a massive transition from organic economy to mineral economy, which is really the classic way to phrase the history of energy in the 19th century. But in fact, wood, water, wind energy are growing in the 19th century. We are using more and more water energy in the 19th century, more and more wind energy in the 19th century. At the end of the 19th century, you got millions of windmills, in the US in particular, which are used to pump water, irrigate fields. Wind energy plays a key role in the history of industrialization and agriculture in the late 19th century, for instance. The other problem with the historiography is that they have taken too seriously the statistical categories. What I mean is that for them, coal is just coal, and wood is just wood, and oil is just oil. But in fact, we have to understand the fact that energies are closely intertwined. I just give you this example. This is another important graph in the history of energy. It is in Anthony Wrigley's book, which is really the classic book, standard text on energy and the British Industrial Revolution. In this graph, you can see the very striking increase of coal. This is the light gray, which will not surprise you. But as you can see, according to my colleagues, wood energy, which is dark gray, decreased during the 17th and 18th century, and then disappeared from English energy consumption by the mid-19th century. And it is true that at that time, British people would not burn much wood in their chimneys and stoves, and all the British steel-making industry was already shifted to coal. Does it mean that British energy system escaped from its dependence on wood? Not at all. On the contrary. To extract coal, you need a lot of wood. So much wood that Britain in the 20th century used more wood as pit props, as timber mining, than Britain burned in the 18th century. And it is even worse than that, because to grow construction timber, of course, you need more space, more acreage of forest than to grow fuel wood. So actually, Britain in the 20th century and until the 1950s and or even 1960s used at least 4, 5, 6 times more forest area than Britain in the 18th century, just to produce its energy, right? To extract coal. And actually, this is true for most industrialized countries. The most impressive example is Russia. Russia in the 1960s, USSR, sorry, in the 1960s used enormous amounts of wood to extract coal. And it was made possible by one canal, which was linking the forest of central Russia to the Donbass region, where the mines in Ukraine imported a lot of wood from central Russia. And it's really the maximum point of wood consumption for energy production in the USSR. It's the 1960s. This is a picture from the Cardiff Harbour in the 1930s. This is just the pit props for the use in the coal mines of Wales. So it's really a very significant amount of wood. So when you think about coal in the 20th century, you need to think about wood. Without abundant wood, abundant timber, there would have been almost no coal, therefore no steam engine or very little steam engine, probably no railways, etc., etc. There would have been no industrialization. Wood is not secondary in the energy system of rich countries in the 20th century. It is central. And the same goes with coal and oil. The idea that there is a transition from coal to oil in the 20th century is clearly wrong for one very obvious reason. Oil is mainly used to power automobiles, and to make an automobile, you need a lot of coal, because an automobile is first and foremost a big chunk of steel, right? And to produce steel, you need coal. Ford company needed 7 tons of coal to make an automobile, to build an automobile in the 1930s. This is more or less the same weight that this automobile would burn in terms of oil. So in the 1930s, a car is just as much a coal technology as an oil technology. Some engineers actually made calculations for the case of Britain in the interwar period. For each ton of oil burned in Britain in the 1930s, 2.5 tons of coal were needed to build the automobile and to build all the steel infrastructure which makes the use of oil possible. To transport oil, to store oil, even to extract oil. Steel tubes, for instance, they represent such a big amount of steel that you can, steel tubes are used to extract oil, that you can quantify them. They are in a separate categories in statistics. And for instance, the US at the beginning of the 21st century used just to extract oil, steel tubes, and this amount of steel is bigger than the consumption of steel in the US at the end of the 19th century. So the oil industry in the US in the 21st century used more steel than the whole US economy at the end of the 19th century. So we really have to think energies and materials as deeply intertwined. They are growing in symbiosis. Most of the time, we think about energy as being in competition, and that's why the idea of energy transition became so popular. But in fact, energies and materials, when you look at a large time scale, you see that they work together. They support each other. Of course, coal and oil are in competition for one specific sector, like motors. Of course, in the 1930s, steam engines were replaced by diesel engines, because diesel engines are so more practical and much less dangerous than steam engine, of course. Nevertheless, these diesel engines, they powered machines which were made of steel and therefore which depended on coal, right? I'm just going to show you some pictures illustrating this symbiotic dimension of the history of energy. This one is a picture of an enormous eucalyptus plantation in Brazil. It belongs to Vallourec. Vallourec is a French company which is specialized in the production of steel tubes for the oil industry. So here you've got the production of wood to produce charcoal, and this charcoal is used to produce steel, and this steel is used to produce oil, and this oil is absolutely indispensable to produce this kind of plantation. I mean, wood is completely dependent on oil. All the machinery depends on diesel, right? And these kind of plantations, their yields is around 40 cubic meters of wood per hectare per year. To give you a point of comparison, Western European forests, beginning of the 20th century, the yield was around 2 to 3 cubic meters of wood per hectare per year. So the yield has been multiplied by 20. But of course, to have this kind of productivity, you need a lot of fertilizer and therefore a lot of methane, right? So this is a good example because it shows that the classic narrative of wood and then coal and then we had oil is clearly wrong. And actually, this plantation produced more charcoal than the French steel industry burned in the mid-19th century when it was at its peak charcoal. So in a way, France has never used as much charcoal to produce steel as today. And globally, we are using much more charcoal to produce steel as any time in the 19th century, simply because of Brazil, which has a very, very important steel industry based on charcoal. Another example, which is close to here, is the biggest wind power plant, floating power plant, sorry, in the world. This is Hywind Tampen in Norway. This is really a technological progress. You've got enormous wind turbines, which are not anchored on the floor. They are floating thanks to an enormous weight made of concrete, over 10,000 tons of concrete. You've got complex computers to monitor the wind, the waves, and so on to keep the wind turbine stable, despite all the active forces, of course, surrounding the wind turbine. But probably the most striking fact about this very special wind turbine is that it is not connected to Norway, because the electricity it produces serves to power the gas rig, oil rig, gas rig, that you can see in the picture. So here you got clean electricity, which is used to extract gas. And this is not exceptional at all. Actually, more and more, Norway is electrifying its oil rigs from hydroelectricity from the continent. In Texas, you've got a skyrocketing of wind power. So you've got more and more wind electricity used to power the oil jack, which are pumping oil in the Permian Basin. This is very common, right? So once again, these kind of energy symbioses, they are still with us today. And the last picture I wanted to show you before advancing in my presentation is from Britain. Actually, it won't surprise anyone in Finland, but the use of wood to produce electricity has grown a lot in the 21st century. We are burning more and more wood to produce electricity. In Britain, there was a coal power plant called Drax. It's close to Leeds. It was a very big coal power plant, which was inaugurated in 1972. And then around 2000, it was converted to biomass. Biomass is a code name for wood. So here you've got wood pellets, which are extracted from Canada and the US mainly. They are transported with diesel engine, of course, to Britain, and they are burned to produce electricity. Each year, Drax burns at least 4 to 6 times more wood than Britain in the 18th century. So we end up with the fine result that after 2 centuries of energy transitions, Britain actually used much more wood to produce energy than it did before doing all these energy transitions, right? And the other interesting factoid about this power plant is that all this wood, which is bigger than wood production of Britain, right? So it's really a significant amount of wood. All this wood represent only 1.5% of British energy. So it shows the kind of impossibility to have the same use that we had with fossil fuels to have it with biomass, except for very specific countries, in very specific conditions, there is not enough materials. And we have exactly the same problem for sustainable aviation fuels. You might have heard of sustainable aviation fuels. I mean, aviation is probably the most difficult thing to decarbonize because batteries are too heavy for planes. So the idea is, okay, so let's use oils, vegetable oils, for instance, or the fats of pigs, for instance. But actually, there are not enough pigs, nor enough vegetable oil to power airplanes at scale. For the case of France, which is a big oil producer, a vegetable oil producer, you would need to multiply by 5 the production of vegetable oil just to satisfy the demand for aviation. So there is not enough biomass to do that. Once you tell the history of energy as it should be told, as the symbiotic expansion of everything, this is really what the global history of energy is about. Everything is growing, and they are growing together, not in opposition. How come that the idea of energy transition became so natural that now everyone is talking about energy transition, that it is obvious that we are in the middle of an energy transition, right? How come that it became natural? The first thing to know is it is a fairly recent idea. For a long period of time, experts, energy experts, never talked about energy transition because they knew that it didn't exist. It does not represent any empirical data. You've got here an example of a futurology proposed by a proponent of solar energy in the 1970s. As you can see, according to this expert, everything will grow. The future is not envisaged as a completely radically different present. It's rather thought as a bigger present, right? You don't have this idea of shifts, right? You rather have this idea of a cumulative growth of everything. There is one, so this is really I would say, the majority way of looking at the future of energy until the 1970s. There's a small group of scientists who imagine the future of energy in a different way. And they are atomic scientists. They were part of the Manhattan Project, and they were convinced that the future of energy depended on atomic energy, and actually on one specific kind of atomic energy, which is the breeder reactor. For them, the question was not whether or not nuclear energy was competitive with coal, which was the question that economists were asking, and most of the economists thought that nuclear energy was not that important because coal was so competitive compared to nuclear energy. For them, this was not the interesting question. The interesting question is that sooner or later, we will need to have atomic energy because coal will be exhausted. The phrase energy transition emerged from atomic physics. At the beginning, it described a shift of an electron around its nucleus, a shift in energy states. So energy transition is a term of nuclear physics, and it was used to describe a kind of energy future by this person, Harrison Brown, who is an atomic scientist who had been through the Manhattan Project, was obsessed with the breeder reactor, and was also one of the first to ask money to study climate change in the US. In 1952, he asked Exxon company for money to study climate change, 1952. This is very early, but it's not surprising when you know a little bit about nuclear literature in the US in the 1950s. In 1953, there is a very important report about the future of energy published by the Atomic Energy Commission. And in this report, there is a chapter on climate change, 1953. In this chapter, you got this very impressive graph, which describes the rise of the level of the oceans, both on the Pacific side and the Atlantic side. So there is a global phenomenon, according to the author, which is the rising of the oceans, and this global phenomenon is caused by the greenhouse effect, which is itself caused by fossil fuels. So for nuclear scientists and the nuclear lobby, climate change was used as an argument to promote their technology. In a way, climate change emerged as a problem to promote a solution, which was nuclear energy. And you have probably seen this curve, the killing curve. So this is a very important curve in climate science. It shows the rise of the content of CO2 since 1958. It's a beautiful curve because you've got this period, this yearly period, and it shows the respiration of all vegetation on Earth, right? And it also shows the long exhalation, the long respiration of industrial civilization since the 1950s. This curve, which is produced by Charles David Killing, and actually Charles David Killing was a student of Harrison Brown, of this character. Most of the research, the early research on climate change in the 1950s is either financed or made by close people associated with the Atomic Energy Commission. There are two reasons for that. The first one I already mentioned. It is that It's a very good argument to promote nuclear energy, climate change. And the other reason is that atomic scientists had in their hand a very powerful instrument called the mass spectrographer, which had made tremendous progress during the Manhattan Project for the building of the atomic bomb. And mass spectrographer allows scientists to measure isotopes, the isotopes of carbon-14, the isotopes of oxygen, so they can have paleotemperatures, and they can study in a much more rigorous way the carbon cycle. So really, atomic energy played a key role in the knowledge about climate change and also in our visions of the future of energy. Because the other powerful argument for nuclear energy was the fact that coal would get exhausted. So we needed something else. And this something else, of course, would be nuclear energy. Marion King Hubbert, you might have heard of him, is the theoretician of peak oil. Marion King Hubbert is a geologist. He worked for the Shell company. But he was also a consultant for the Atomic Energy Commission. And in 1956, he wrote a very influential paper where you've got this fantastic graph. If you look at the lower graph, you can see that all fossil fuels have this shape of a very narrow peak, a frail peak. But how come? It is because it is compared with the unlimited energy plateau that you can reach if you've got the breeder reactor. And you also have to look at the time scale. All fossil fuels are contained in this narrow peak because you look at the history of humanity over 10,000 years. So of course, at this time scale, there is not so much energy in fossil fuels. And here you've got one of the first representations of energy transition indeed. All fossil fuels will come to an end, and it will be replaced by the unlimited source of energy, which is the breeder reactor. But the end of fossil fuels is midway between now and 1,000 years. So it's in 4 or 5 centuries, because they know there is a lot of coal under the ground. And they know that atomic energy, it will take time to spread globally. And they know it is difficult to use atomic energy to power automobiles or planes and so on and so forth, right? So what is strange? It is that we have recycled a very heterodoxical, marginal understanding of energy dynamics, the idea of energy transition, to reflect on the climate crisis. What is strange is we have used this idea of energy transition, whereas at the beginning it was imagined as a long, like a plurisecular process, like taking place over 3 or 4 centuries, and which would take place because of the growing scarcity of fossil fuels. So there will be a strong cost incentive to shift away from fossil fuels. We have recycled this very wrong understanding of energy dynamics for the climate crisis. Because for the climate crisis, we have to do the energy transition not in 3 or 4 centuries, but in 3 or 4 decades. And we have to do it despite the fact that there is a lot of coal under the ground, right? So how come that this scientific scandal was possible? To understand that, we have to go back to the 1970s, which is really the key decade for the energy transition. At the time, the big topic was energy crisis, because of the oil shocks of 1973 and 1979. And energy transition was used to describe any kind of solutions to solve the energy crisis. So in the 1970s, it could mean more coal, because coal was increasing energy sovereignty of the US, for instance. Right? The first important person to talk about energy transition in the public sphere, in the media, is an American president called Jimmy Carter. In 1977, he made a very interesting speech on television. You can watch it on YouTube if you're interested. And he said that in the past, the US has done 2 energy transitions, one from wood to coal, the second from coal to oil, and now, facing the energy crisis, the US needs to do a 3rd energy transition. And he's commenting on this graph, where you can see, indeed, or it seems two very nice and very clear energy transitions, right? So he's commenting on this graph, which is extracted from the US National Energy Plan that he's presenting on television to his citizens, to the US citizens. This is a very original graph. The trick is to put everything in shares. This is the share of wood, the share of coal, and the share of oil in the US energy mix. Normally, people at that time would rather use this kind of graph to talk about energy dynamics, which of course brings you a different understanding of what is happening. It's not the word energy transition that comes to your mind if you look at this graph, whereas if you see this graph, yeah, it seems quite convincing to explain that there had been two energy transitions. So I inquired and researched the origin of this graph. It was stolen to this scientist, Cesare Malchetti. I had the chance to interview him before he died recently. I think he's the key character in the history of the idea of energy transition. Cesare Malchetti, as an Italian scientist and atomic scientist, is obsessed with nuclear energy. And according to him, the future of energy belongs to atomic energy plus hydrogen, because he understood that for atomic energy to really become important, it needs to escape the small market of electricity production and conquer the vast market of transport and therefore oil. It has to really replace oil. So to do that, you need a liquid, which is hydrogen, liquid hydrogen, liquefied hydrogen. The way he sees the future, he saw the future was that we would make enormous atomic power plants on barges, on floating barges, which would be in the middle of the oceans. Why in the middle of the oceans? Because the atomic plants, the nuclear plants would be so big that it would create so much heat that you needed all the water in the ocean to cool the nuclear power plants. And these nuclear power plants would electrolyze water to produce hydrogen. It seems kind of crazy, but actually, at one point, he was taken seriously, especially in Japan, where he had something of a success in Japan and was listened by the highest authority in Japan at the end of the 1970s. He is considered as the founding father of the hydrogen economy. In 1976, there is a new journal which is created, the Journal of Hydrogen Energy, and Cesare Malchetti is really seen as the kind of inspiring figure of this idea of hydrogen economy. If you go on the internet, you can have a look at the first issues of this journal. It's quite a fascinating read because we have all the technologies that we are now talking about. They're already on the table, and honestly, it hasn't gone very far. There is several articles on the hydrogen airplane, and the problem they mention are exactly the problem that engineers are now facing to imagine a hydrogen airplane, right? Anyway, so Cesare Malchetti had this kind of Dr. Strangelove dimension, right? But he was also interested in the time for atomic energy and hydrogen to become the dominant source of energy. And to do that, he used history. And he made really some original work compiling data at a global level on the evolution of the global energy mix. He's one of the first to do that, actually. And with this data, he inferred a mathematical model which would allow him to predict the future. And it seems quite convincing. If you look at this graph, you can see that the empirical data seems to fit very well the curves derived from his mathematical model, right? It seems very, very convincing. And this graph, which has been extremely influential to reflect on energy, it really gives the impression that there are some waves in the history of energy, that the history of energy has this kind of inner dynamic that leads from one source of energy to another. There was the wave of coal, then the wave of oil, and then there will be the wave of natural gas. On that point, actually, Malchetti was perfectly right. Natural gas played a very important role in the energy mix of European countries, for instance, after the 1960s. And then there will be the coming wave of what he calls solfus, which is solar and fusion. This graph, has been looked by many different experts, and now it is criticized, especially by an important historian of energy and actually one of the best historian of energy, Václav Smil. Perhaps you've heard of Václav Smil. He's a Czech historian of technology based in Canada. And Václav Smil criticized Marchetti because, as you can see, he was wrong on coal. According to Marchetti, coal should have more or less disappeared by 2020, whereas coal has actually become more important since the 1970s. So he was wrong on coal, that's true. But this critique is very unfair, because Marchetti was actually working in a group of experts called the IASA. The IASA is really an important place for energy modeling today. And it started in the 1970s. It's an international research institution, which is near Vienna, in Luxembourg. It was, the originality of this institution was, it was an East-West initiative, so you had scientists from the Eastern Bloc and scientists from the capitalist countries as well, working together on global problems. And at IASA, they were asked to find models and scenarios which would demonstrate that there was a smooth energy transition out of fossil fuels in 50 years, that it was possible to escape fossil fuels in 50 years. The energy group was set up in 1972, and they used computers to demonstrate that it was indeed possible to find ways to imagine, first of all, an increase of coal to cope with the rising cost of oil, but then very quickly a rise of nuclear energy to escape from the dependence on fossil fuels. The aim of IASA, if you want to summarize it, it was to answer the Club of Rome. I guess you've heard about the Club of Rome and the Limits to Growth report. It was a really a spectacular report which really shocked global opinion in 1972 when it was published, which demonstrated, with using mathematical models, that we basically after 2030 there would be potential catastrophes because of economic growth, be it because of lack of resources or pollution. And it was really the kind of bête noire for most of the economists of the 1970s, and the IASA was part of this answer to the Club of Rome report. Interestingly enough, these models, MEDE and MESSAGE, they are still used today in integrated assessment models, the models that are used by the IPCC to create net zero scenarios. So here actually we are talking about the genesis of the models that we use to reflect on the trajectory for carbon neutrality. It started here. It started there, sorry, in 1972. And Marchetti was very critical of this work. Basically, he didn't think that using computers to predict the future was the right method. Why? Because according to, basically, you can create as much scenarios as you enter parameters in the computers. And for Marchetti, the history of energy was much more deterministic than that. And what he wanted to show with this graph was that the idea of getting out of fossil fuel by 50 years was rubbish, that there was such a strong inertia in the global energy system. The global energy system, when you think about it, it is an enormous thing. It is made of mines, of capital which are invested. It is made of consumers, of machines that are already installed. It is made of cultural dimensions as well. It is an enormous thing, right? And this enormous thing has a very strong inertia. So the depressing morale of my small story, it is that the most pessimistic forecaster of the 1970s turned out to be far too optimistic on our capacity to get out of coal, right? So actually, when Václav Smil criticized Marchetti, he should add that he was probably one of the most reasonable forecaster of the 1970s. But even him, who was pessimistic, turned out to be far too optimistic. The important thing is that the idea of energy transition started at that time to become something of an expert discourse, which was not the case before. before the mid-1970s, experts would not talk about energy transition. And then, after the 1975, energy transition became a subject of expertise, and it was new. And energy transition encountered enormous success. It was very successful among environmentalists. Basically, if you look at just 2 or 3 years after the discourse of Jimmy Carter in 1977, Friends of the Earth, the Club of Rome, the World Resource Institute, they all made reports on the energy transition. And for them, it was solar energy, renewables. And the problem is that the environmentalist movement took a wrong understanding of the dynamics of technologies and materials. They, in a way, strangely enough, they took the vocabulary and the way of seeing of atomic scientists. The most interesting case is Amory Lovins, who published a very influential article in 1976 on the soft energy path. And according to him, the US could get out of fossil fuels without nuclear energy it would take between 30 and 50 years. Because renewable energy had this capacity of expand very quickly because it was not, since it's not dangerous as nuclear plants, there is no rubber tape. It was also a very neoliberal argument in favor of renewable energies. So at that time, really a new understanding of the material world emerged as something very flexible, as something that can shift very quickly. And it is a new cultural phenomenon. The idea of energy transition was also very fashionable among oil executives when the problem of climate change started to emerge. In 1982, important climatologist Jim Hansen invited Edward David to give a talk to climatologists worried about climate change. And what is interesting, it is that in 1982, Exxon was not climato-skeptics. They were actually financing some good research on climate change, but they were transitionists. And the discourse of Edward Davids, the head of Exxon R&D, is very interesting because I think it's the discourse that the oil executives, at least in Europe, used after 2000. For them, of course, there is climate change. It is true. It's not a question. The interesting question is what will come first, the climate catastrophe or the energy transition? And it was quite an astute way to present the problem because many climatologists also presented the problem that way. And they had this kind of forecast. Climate change would become sensible by 2000. People would understand that something has changed in climate by 2000. I'm talking of articles from the mid-1970s. So climate change would become sensible by 2000. It would have economic consequences by 2020, on agriculture in particular, and it would be truly catastrophic by 2070, 2080. But when you say 2070 or 2080 in 1970, it's in science fiction. And the reasoning is, of course, we have time to do an energy transition. We all know from past experience that it takes 50 years to make an energy transition, which is, of course, rubbish, right? We don't know how long it takes to make an energy transition since we have not done any one yet. Energy transition was also very, very palatable for neoclassical economists. This is really probably the biggest scientific scandal of the late 20th century. It is the way energy economists of the energy crisis of the 1970s took in charge the question of climate change. And if we all talk about energy transition, and if economics of climate change is really focused on this idea of energy transition, it is because the climate economists, the first climate economists, were actually energy economists of the 1970s. And they recycled their theories to cope with the energy crisis. They've recycled that on the climate crisis. The best example is William Nordhaus, Nobel Prize in Economics for his work on climate change, is actually the first economist to have ever written on climate change. And here, the transfer from the energy crisis to the climate crisis is very clear. In 1973, he wrote a paper on the energy crisis. So at that time, oil was getting more and more expensive. Actually, the price had quadrupled in a few weeks after 1973. And there were discussions about should we ration the use of oil in the US? Should we use rationing, just as it had been done during World War II? And Nordhaus explained that it was counterproductive. It would be a pity to restrict the consumption of oil. And since oil was expensive, it meant that it had to be extracted now, because it is expensive. Because in 20 or 30 years, there would be the breeder reactor, which would make oil obsolete. So we should not underestimate technological change when we make economic decisions, right? That was his argument. 2 years later, he's at IASA in Austria, and he works with Cesare Marchetti. He's actually initiated to the question of climate change by Cesare Marchetti, and he makes exactly the same reasoning. There is an issue with climate change. Does it mean that we need to restrict our consumption of fossil fuels? Certainly not, because it will be so much easier to do the energy transition in 20 or 30 years when we will have the breeder reactor, when we'll have the proper technology to do the energy transition. This is what economic calculation shows as optimal. Let's not try to make something difficult now. Let's do it later when we'll have the technology. And at that time, he called this way of thinking about what to do the backstop technology. We have to wait to have the backstop technology. And there will be a backstop technology. Just as facing the energy crisis, actually the US economy will not collapse because of oil scarcity, because we have the breeder reactor. In the same way, there will be a backstop technology for climate change. So in a way, energy transition was used as a theoretical device to justify inaction, delay. It is a delaying tactics in the economics of climate change, which started in the late 1970s. And lastly, energy transition was extremely palatable for governments. I mean, if you want to take seriously the problem of climate change, actually very quickly you have to talk about the reduction of energy consumption, especially of fossil fuels. But it's much easier to sell the idea of energy transition. If you look at the creation of the IPCC, you see that this body of scientific experts, which is now considered as a kind of big defensor for climate, it was not its aim when it was created. When the IPCC was created in 1988, there was already a small group of experts called the Advisory Group on Greenhouse Gases, which had been set up in 1985 by the World Meteorological Organization and the United Nations Programme for the Environment. And the Advisory Group on Greenhouse Gases had a very simple recommendation. Basically, we know there is climate change. We know we have to act. And they proposed to cut fossil fuel emission by 1/4 before 2000. In 1988, there is an important conference in Toronto where there are already governments taking part at the conference. And the final declaration of the conference explained that we have to aim for a reduction of 25% of CO2 emissions by 2005. So a very ambitious goal indeed, right? Instead of doing that, we have more or less doubled CO2 emissions since 1988. So we have fully followed a very different path. Anyway, so when the US government heard about this conference and this final declaration, basically they fell out of their chair. What this bunch of climatologists and UN bureaucrats, who do they think they are? I mean, it was out of question to let climate expertise proliferate outside some kind of control. And that's why the important letter in the acronym IPCC is I for intergovernmental, not international. And when you look at the diplomatic correspondence from the US Department of State to its representative at the World Meteorological Organization, the aim of the IPCC is crystal clear. The point is to put back government in the loop and to gain some control to the definition of the discourse on climate change. And what the US government explained is we need government to nominate experts, so it's not a scientific thing, it's a government and science thing. And we want all the ministries to participate, which means we want experts nominated by the Ministry of Science or Research or Environment, whatever, but we also want the ministries of energy, or industry, or agriculture to nominate experts. And we also want experts nominated by fossil fuel companies, to put serious people in the production of knowledge and consensus. When the IPCC was created, the head of IPCC Group 3 was Robert Weinstein, the guy with the hat. Robert Weinstein is openly climato-skeptic. It is quite strange to realize that the chair of IPCC Group was climato-skeptic, but actually the chair of Group 2 was also climato-skeptic. He was also a climato-skeptic. He's called Yuri Israel. He's a Russian meteorologist, one of the few meteorologists at that time who had doubt on the reality of climate change. Robert Weinstein was also the chief of the US delegation at the 92 conference in Rio, a very important conference which set up the UNFCCC, right, the United Nations Framework on Climate Change. And before going to Rio, he took his order from John Sununu, the chief of staff of George Bush. And they had a very interesting discussion. John Sununu told Robert Weinstein, at Rio, first of all, do not commit the US government to any target of emissions. So no target. It is out of question to sign a treaty which would in any way constrain the consumption of energy by the US economy, of course. Second, do not promise any money, because all this question of climate change is just a pretext for poor countries to ask money from rich countries. And they also saw all this issue of climate change as just a commercial argument in the trade negotiation from the European countries, which had and still have a lower carbon intensity. So for them, it was just a kind of pretext in international trade negotiation between Europe and the US. It had nothing to do with the planet. So no money, no target, play the technology card, which means talk about technological solutions. And it's true that if you look at what George Bush father was saying on climate change, it was play the technology card too. He made a famous speech called the White House effect during his campaign trail in 1988. And the White House effect is the effect of the power of the White House, the power of the US presidency that will fight the greenhouse effect. And it will fight it through technological solutions. At that time, you got spin doctors from the Republican Party explaining that, okay, we are losing the battle on the issue of the science on global warming, but what is important is to rely on the trust on technology. The US citizens, they love technology. So talk more about technology, about technological solution. So really it is part of a broader discourse which originated from delaying tactics in the Republican Party. Anyway, play the technology card, and Robert Weinstein was head of IPCC Group 3. Now, let's look at the reports produced by the IPCC Group 3 since 1992. What do they talk about? They mainly talk about technology, right? Most of the discussion is about supply side, about technological innovation, technological solution to climate change. All the questions of demand reduction, the problem of inequalities are virtually absent. All this is really secondary in the reports. The technology they talked about, at first it was mainly nuclear energy, then it became renewables, and then it became carbon capture and storage. I don't know how much you know about carbon capture and storage, but I just want to devote like the 5 minutes I've got left on this peculiar technology. So the idea of carbon capture and storage is really crucial in all models if we want to reach carbon neutrality today. because, as you know, there are some sectors which are very difficult to decarbonize, so we need negative emissions to compensate for the remaining emissions from the economic system, right? Carbon capture and storage, it really started from the fossil fuel industry. From the 1990s onwards, the fossil fuel industry financed research on carbon capture. At the beginning, it was just a way to protect their investment, coal power plant, gas power plants, from the critique of coming from environmentalists and the problem of climate change. At that time, it was seen as rubbish. In the 1990s and early 2000s, you got plenty of reports explaining that carbon capture is not doable. It is too expensive. It necessitates too much electricity. It depends on polluting chemicals to absorb the CO2 out of the chimneys. You need sorbents, which are not very nice, and they degrade, and then you have to dump them in the environment. So it's not a good idea. In the 2001 report, the IPCC Group 3 itself said that it makes coal electricity more expensive than nuclear electricity. So what is the point, right? So it was not seen as serious. And then in 2001, the US government, the Norwegian government, and the Canadian government asked the IPCC Group 3 to write a special report on carbon capture and storage, which was published in 2005. And this report completely changed the status of carbon capture technology. Suddenly, it became doable, not that expensive, potentially very important. Like, we could store 2,000 gigatons of CO2 on the ocean's floor, for instance, creating CO2 lake. So this is a graph from this report. You know, they imagined that we could just store CO2 in a liquefied form and dump it on the ocean's floor because there is so much pressure and it is so cold that CO2 stays liquid, right? Anyway, this report, when you look at the references, well, they most come from the fossil fuel industry, which is not very surprising. It is where the science is produced, right? But it is quite interesting because in this case, you see that the IPCC has given scientific credibility to a solution which was thought as rubbish by most experts before. And this report really changed the scientific status of carbon capture and storage, which what was seen as a kind of false technological promise, clearly linked to specific industrial interests, became a potentially green technology, an important innovation, a rightful endeavor. So you got an explosion of papers on carbon capture and storage. You got journals created on carbon capture and storage, right? So, the story is important because in the middle of the 2000s, more and more models started to integrate carbon capture and storage to reach carbon neutrality. And models, integrated assessment models, love carbon capture and storage because it makes carbon neutrality seem cheap. You capture CO2, but later, in the second part of the 21st century. And then you put net present value, which devaluates the future. So it seems cheap, seen from 2015. So in 2014, the report of the IPCC Group 3, across the scenarios they proposed, you can see that the biggest, this is the emissions, negative emissions, so this is carbon sink, basically. The biggest carbon sink in the world becomes the electricity sector. How come? To do that, you use biomass to produce electricity. Remember Drax power plants? You burn wood to produce electricity, but you capture the CO2 out of the chimneys, so you create negative emissions because the tree, when it grows, of course, it captures CO2, then you burn the tree, you create electricity, you recuperate the CO2 out of the chimney, and you dump the CO2 under the ground. So 10 gigaton of CO2 in this is the median scenario. The extreme scenario is actually 20 gigatons of CO2. Just to give you a point of comparison, the global production of wood is 4 billion cubic meters. So it's really the global production of food represents just a fraction of the carbon that they imagine would be used in these biomass power plants. Right? This is totally rubbish, totally rubbish. And everybody knew it's totally rubbish. Right? But it's important because 2014 is just 1 year before 2015, which is not a great news. But anyway, in 2015, the Paris Agreement was signed, and it was signed on these false promises. It was signed on empty technological promises. It was based on these technological solutions that do not exist, right? And I think it has created a lot of confusion. It also created delays in the right action that we should take. And it creates also political discredit, because of course the government cannot achieve the 2-degree target. I mean, it was not even possible in 2015, and it's of course not possible now. If you look at, not at net zero scenarios, but at forecasting, it is rather this kind of future that we're going to have. This is the reference scenario of the International Energy Agency of last year. So you can see a very significant growth in renewables because solar energy is cheap and it is very easy to install. So it is really skyrocketing in many countries, especially in Asia. You see a significant decrease in coal because the coal market is impacted by, of course, this growth in solar panels, but not a disappearance of coal, not at all, actually, just a diminution of 1/3. But as you can see, oil and gas are remaining at a high level, right? And this is not surprising at all. And it is completely natural when you know a little bit about the history of energy, right? There is no energy transition coming. And this is in part because energy transition is not a serious notion. It is a slogan, right? We have been fed a slogan, and a slogan has really framed the discussion around a very serious issue, which is climate change. And to just wrap up the argument, what interested me as an historian is that this slogan seemed plausible because of a false history. It's because we have been accustomed to this idea of energy transition as something real, as something which had happened in the past, that we have accepted, this very strange vision of the future. So energy transition actually use a false history and project it on the future, which remains to be built from the ground. Thank you very much. I hope I was not too long, and thank you a lot for your attention.
Sakari, you want to sit in the middle?
Thanks. Would you like to sit here in the middle?
No, it's okay.
Right. Well, Mihiru is grabbing some water still for us, but many thanks already for this wonderful presentation.
Thank you.
So we have some time now for our discussion here before opening the floor to everyone else as well. There will be many things to ask, but maybe I'll reserve the first question for me.
Thank you.
It's a really convincing story that you tell, and the book is amazing in telling it. As you quite clearly show, the transition talk is in many ways illusory and unfounded. So how do you think that especially these academics that you mentioned, like for example the book Power to the People, which is a reference work, so it's actually a good book, why did these people who are active in the history of energy accept this talk?
Okay.
It's really strange to me because, as we discussed before, it seems that all of the facts that you recount in your book kind of are there. And you mention in your book that the notion that there was no transition is a statistically trivial observation, direct quote from your book. So how did these academics come to accept it?
Okay, I think it's because they had a different question in mind than the problem of climate change. What they were interested in was economic growth and the history of economic growth. There are many economic historians who are interested in the history of energy to understand the condition for economic growth, the takeoff. And if you ask this question, it can make sense to really focus on the share of coal, right? Which become a sign of industrialization, right? So I think it's because they had a different question, and relative shares are pertinent to study this question, but when you study, if the question is climate change, then this is not the right metric. We need to look at absolute values, right? The tons of coal, the ton of wood, the tons of gas, and so on and so forth. So I think that's probably the main reason. Then there is I would say a less scientific reason, but it plays an important role. Imagine yourself as an historian of steam power in the late 1980s, early 1990s. Nobody cares about your work because steam power is kind of boring. But if you present yourself as an historian of the energy transition, of the first energy transition, then suddenly you become much more interesting. And suddenly you can pretend to provide advice to the deciders about how the Brits managed the first energy transition and how we can now derive the information to manage properly the next energy transition. This move has been made by several colleagues, and actually the transition studies, which is a whole academic field, booming actually academic field, is based on this wrong premise. You know, studying the past to enlighten the future, which is a very classic way of making history relevant. My take on that is completely the opposite. Actually, I'm just putting history on page compared to the actual expertise today. I mean, the starting point is rather, okay, let's understand what specialists in life cycle analysis, specialists in ecological economics are saying about energy, and what does it mean when we study the dynamics of energy from the 18th century to the 20th century, right? So it was rather to enlighten the history from the present, rather than the other way around. I don't know if that answers your question, yeah?
Absolutely.
Yes, thanks. So it's my turn. So what do you think the roles of modelers? So you mentioned different mathematicians, modelers, economists, and in your story, one of the biggest scandals is Nordhaus, who, by the way, got a very prestigious prize in economics for his work, and then there's this criticism of unrealistic assumptions, and economists are often criticized for, having very unrealistic assumptions in many domains. But it's not only economists, but there are different kinds of modelers. And in fact, in the IPCC, not all integrated assessment models are cost-benefit type. So there are more serious modelers involved. And then how is it that kind of historical work you do are not really integrated into this kind of thing? So do you see a way for this kind of a modeling exercise to become more realistic in a relevant way?
Yeah, I mean, what's in the models is very difficult to crack. I mean, it's really a black box. And I think that's really a problem for the discussion about the future, because they kind of monopolize the discussion, but we don't really know what their hypotheses are and what is in the model or not. Mm-hmm. I mean, I had several discussions with people really working with these models in Paris and elsewhere. And when I ask concrete questions about, do you take into account this or that, the answer is never very clear. Mm-hmm. I mean, I'll just give you an example. If we don't extract almost no oil, then we don't have bitumen. And bitumen is useful for roads, right, to make the pavement. So if we don't have bitumen, we need more cement, which means that you need more coal to produce the cement. So, I mean, is it taken into account in the model? In the same way, if we don't extract oil and gas, we have no more sulfur. And sulfuric acid is extraordinarily important in all sorts of industries, especially for phosphate to produce fertilizers, but in metallurgy and so on and so forth. So do they take into account that? Do they take into account the fact that you need to open new mines of sulfur to replace for the sulfur that we extracted from oil and gas, right? So you got all sorts of problems when you think about, and when you really imagine the end of fossil fuels, you suddenly start to understand that there are many difficulties, choke points in a way. I never had a clear answer on that, right? It's, most of the time, yes, of course, it's in the model, but yeah, I'm not sure. So I think, yeah, we need to have a really kind of democratic discussion and scientific discussion on what these models say. So I think the first problem is black boxing and creating a difficult scientific discussion, and actually a much specialized scientific discussion. The second problem is it's a very abstract field. You know, in the end, it ends up like they are not talking about technologies, and they are talking about different kind of models and not actual technologies and actual requirements for. So that creates a more abstract discussion, which is also a problem. And then I think probably the biggest problem is that they are very, because you say that not all models are cost benefits, but they try to minimize the cost of carbon neutrality. So when there is any hope of a cheap solution, the models just rush on this. They really like the cheap solution, cheap technological solution. And probably, but this is solvable, there are two last problems. One is that for the moment, they have not imagined kind of redistribution at the global level, which means they are under the condition of Pareto optimality. You cannot improve the situation of someone without degrading the situation of someone else. There is no transfer of wealth, which is very convenient for rich countries, of course, but which is problematic when you think about planetary boundaries. And there was a last problem, but I forgot which one it was. Sorry. Yeah. Sorry.
Well, we can get back to that.
Yeah.
I might actually add to this question of Mihiru's, this modeling thing and kind of like thinking through these graphs and models. In your book, you have a sub-chapter, I think, that is titled something like The Lesson of the Fruit Flies or The Lesson of the Flies or something like that, where you recount the history of logistical curve. Yeah. So could you elaborate a little bit on that? Because you kind of make it seem with your like impossible to counterpoint that there has been no transition, and then you take the history of logistical graph, which comes from fruit flies. I ask, it really seems fantastical that people actually accept this stuff and then go on and apply it for thinking of spread after new technologies or anything. So could you tell what the logistical graph is and a little bit on this?
Okay, so this is the S-curve, you know, the diffusion curve. I guess you have seen that already. So this is a very simple mathematical equation with two parameters. And it has been used to map the replacement of technologies, I would say from the 1960s onwards, quite intensively. And Cesare Marchetti, I talked a lot about Cesare Marchetti, but I have to mention one last thing, is the first to apply this logistic curve on energy dynamics. Energies, according to him, replace according to this beautiful S-curve. This is the starting point of the idea of energy transition. And it doesn't work, because for the reason I mentioned, you cannot use this model to reflect on energy dynamics. Energies are not the same as technologies. They do not replace each other. They are in symbiosis. That's why this argument of symbiotic dimension is important. And this S-curve, I was interested in, where does it come from? And indeed, it comes from neo-Malthusian thinkers, population biologists, who were reflecting on the carrying capacity of certain environments. And the first to use it in an important way is Raymond Pearl, an important American biologist, who, so if you take the population of flies in a bottle, it makes an S-curve. So it grows, and then it saturates the environment, and then, of course, it collapses if you don't feed the flies, obviously. And then you apply that on human phenomena, like the population of Algeria. According to him, given the colonial statistics made by the French government, the population of Algeria would really, it would saturate its environment at around 6 or 7 million people. Well, wrong. Actually, Algeria must be over, I don't know, 60 or 70 million people now, right? So it was clearly not the right tool, but it was really the beginning of the use of logistic curve to map all sorts of phenomena. And it was used by by Marion King Herbert very early on in the 1930s, and then used by Cesare Malchetti. And I think it really plays a central role in the intellectual construction of the idea of energy transition indeed.
Mm-hmm. My question?
Sure.
Is it? Yeah, so I think we plan to ask about energy amputation. So it seems like only logical conclusion of this presentation is that in order to have less emission, you need to use less energy. But does that mean that you need to have a GDP degrowth? And how has it been received? Like because you have been doing this touring with this book for some time now, and this kind of relevant information and part of the resistance come from the fact that we need to degrow the economy, which no one likes. Mm-hmm. I mean, Finland is now experiencing high unemployment rate, and so there's a lot of literature. And how do you sort of connect your historical work to that type of literature, which, you know?
Okay, for the phrase energy amputation, I think it's only at the beginning of the book that I use this phrase. It's because because energy transition, of course, it seems very palatable, but actually it is useful, and it's right to talk about energy transition, about the climate, only if the energy transition is really an energy amputation. If we really get rid of fossil fuel, the point is not just to have renewable grow and fossil fuel stagnate, right? This is not enough. It just delay the global warming, but it does not stop the global warming. So what we really need to do about climate change is amputate the energy system from like 80% of its source, which is still today. I mean, 80% of the global energy production is still based on fossil fuels. Just to remind us of the enormity of the task. Right? Then, of course, I think we should stop dreaming about solving the issue, perhaps cracking the issue. Perhaps that it's part of the thing that you can't solve, actually. That climate change will happen. We can delay climate change by taking strong action. I think the amputation is mainly on the sectors where we don't have technological solutions. Mm-hmm. I think we could differentiate between the sectors where we've got, really efficient technologies, like electricity can be decarbonized in great part, but all the rest is different, and it's really all the rest, and all the rest is quite big. Mm-hmm. It is 60% of the emissions. And it includes vital stuff, like food. I mean, you should remember that food is actually the second biggest emitter after electricity. It is food. Transport, okay, of course, the electric car is better than the petroleum car, but it is still based on steel, on metallurgy, and so on, which are dependent on fossil fuels. So it's certainly not zero emissions. So I think it's just if there is something, the book is not aimed at proposing a kind of political agenda or whatever, because I think intellectuals tend to overestimate their importance. I'm surprised by how many colleagues on this peculiar topic became kind of social entrepreneurs. It's quite striking. And it is on this topic, which is probably the topic on which we have the least influence on, right? Because it's at the global level, we are talking about the real, the most, what's at the basis of industrial civilization, of food, of maintaining the human population. We are talking about all that, and suddenly we pretend to have great plans for the world, which seems to me really strange. Anyway, so the book is really clearly not proposing any green utopia or whatever, but I think we need to have a serious discussion on what is useful CO2 and what is luxury CO2. A serious political, scientific, and democratic discussion. And the problem is, because of modelers, we didn't have this discussion. Because of modelers, we are just talking about technology and now about negative emissions, which are rubbish. Mm-hmm. So we need to have, there will be CO2 coming out of the world economy by 2050 and even later. That is certain. The important question we need to have now, discussion we need to have now is to do what? For whom? And what is the welfare associated to this peculiar ton of CO2? And it's it's really what bothered me most about the idea of energy transition. It prevented us from having this difficult but important discussion.
If I may continue a little bit actually on that still before another question. You write that this energy amputation is without precedent and it has to be carried out, I quote, by a sheer power of will. So probably for these and many other reasons you listed and list in the book, there is no historical case that we could refer to, especially not in the history of energy. But do you think that there is, in any other history, aside from energy, political, whatever, any case that we could really look at and learn something useful?
I mean, I mentioned the case of mercury and asbestos, where you had a really sudden decrease thanks to international prohibitions. But of course, it's not really applicable to fossil fuels, as I guess you know. But if we were really serious, I think we should be talking about, yes, prohibition. I mean, what shocks me in the IPCC Group 3 last report, the word ban, I think is present only 3 times, 2 of which is to say that bans are unpopular. Well, sure they are, of course they are, but we should be talking about that. Of course we should be talking about, prohibiting, I don't know, private air jets, I mean, or big cars, or, of course it should be part of the discussion, of the scientific discussion, and it isn't, because they want to remain policy relevant. But the result of that is they are completely irrelevant. Right? So no, I mean, it's if we had earlier in the 1970s, like US senators, I remember I was struck by the fact that they would happily talk about rationing. In 1979, there is a fantastic discussion around climate change, CO2, and one of the organizers, a senator organizing the discussion, I think that the only serious solution is to talk about rationing. And this has completely been obliterated, completely, right? From the scientific discussion, which is significant of what has happened,
Yeah, absolutely. I could continue on that, but perhaps I'll ask this one burning question, which is a little bit more technical on this transition critique. There's many people, after reading your book, in some reviews and some discussion and conversations that I've encountered, some people think that you draw a too pessimistic picture because you look at the global aggregates and not what is locally happening. Some people argue that real transitions happen locally, and that's why the global inertia is leading us astray. For example, you may refer to the Finnish electrical grid as an example, which is almost like 100% of fossil fuels. So how should we understand here the relationship between the global and the local?
I think it is true that the global can obscure the local, but the reverse is also true. And the problem that we invoke, like cases of small and rich countries decarbonizing the electricity, and we project that on the global energy system. And that's probably a dangerous step, very not rigorous one at least. So, I mean, many countries have decarbonized their electricity system. And not only actually rich, Brazil, I think, has an almost decarbonized electricity system because of hydraulic energy. Nevertheless, emissions from Brazil are growing, and because of deforestation mainly, but many other reasons. So we just have to remember that electricity is different from the rest of the discussion. It's a different sector, right? Because there is no materiality. It's transforming energy from the sun in electrons. It's very different from making cars. It's a different thing. So then the other thing is, I mean, it's very well known, but like for the case of Britain or France, I made some calculations. If you take the coal used to produce the imports of a country like France or Britain, it's around 50 million tons of coal per year that Britain and France are importing through other goods, right? All the coal required to make these goods. I mean, for the case of Britain, it's much less than the maximum, that the peak coal. It was at 200 million tons in the 1910s. So, of course, Britain has reduced a lot its consumption of coal, but it is still 50 million tons, right? And for case of France, the maximum coal consumption was around 70 million tons. 50 million tons, we are not that far from the maximum coal consumption of France. So I think we should be really cautious when we say, Britain has really, has gotten rid of coal. Not really, actually. The British way of life is still dependent on coal.
So do we only speak of electricity because that's the convenient part, or what do you think is the reason? Like, why just electricity? Because, of course, as you said, electricity is so easy to, well, not easy, but it can be decarbonized.
Yeah.
And usually when people speak of decarbonization, they implicitly mean electricity. So is this the reason that it's just the convenient way? Or?
I think there are two reasons. First, because it gives hope, which is important. And second, because then the reasoning is, but we're going to electrify everything. We live in a world made of electrons.
Right.
Okay, so let's ask another exciting question. So you have a provocative sentence in the book that transition is an ideology of capital. Mm-hmm. So we want to dwell on this thought and a little bit, to elaborate on that. So in a chapter that you didn't discuss in the presentation, chapter 9, you talk also about these technocrats in the 1920s and 30s in the US. It's very interesting because a lot of, just like we see all these fancy technologies already in the discussion in the 70s, we see this universal basic income and all these, working hour reductions and all these socialist policy ideas already 100 years ago. Yep. So I'm curious about, because these people are dreaming of not the energy transition, but economy transition, right? Steering away from inefficiency, this is the word, the inefficiency of capitalism to something more efficient. So do you think that they were also a bit guilty of some kind of techno-optimism in a different kind, or because this is relevant for the contemporary discussion of UBIs and...
First, about the ideology of capital. I think energy transition allows capital, investment, innovation to be on the right side of history. Mm. Because if you talk about energy transition, you talk about, money, about technologies, innovation, and so on. And who can do that? Who can provide that? Big companies. So I think it was important after 2000 until now, basically. And now perhaps we have shifted. Perhaps the era of energy transition is behind us. Perhaps now it's energy sovereignty, the key topic. It's once again technological competition between the West and the East, between the US and China. These are the major topic of today's discussion. It's no longer energy transition. So my book comes quite late in the end. It's a bit like the epitaph of something which has nourished international discussion, especially around the 2015 agreement in Paris, probably, right? But I think in many corners of the capitalist world, they have moved to something else, right? I would also add that if you look more in detail on the period of the 1980s, 1990s, governments knew that energy transition was rubbish. It is very clear in the US. They know that there won't be any energy transition simply because also China is booming, so there will be more coal in the economy in the 21st century than there was in the 20th century, so they knew it was rubbish. And the key topic was adaptation. And I think there was really why nothing happened so much at that time, in the end of the 20th century. It's because rich countries were convinced that they could adapt, that 3 degrees warming is acceptable. They can cope with 3-degree warming. There are very clear reports from the US in as soon as 1976, showing that, the US economy and they have the means to buffer the shock. They are very techno-optimistic. For instance, they say that for agriculture, they will have GMOs, like crops that would resist drought and so on, this kind of stuff. But they also point to interesting problems. For example, they talk about, the agile soil, they contract with the heat, and that creates a fissure. It creates problems for the foundations of buildings. And it starts to be really costly. So they mentioned that in 1976. So they really anticipate all sorts of problems which are real. So they are doing some serious work on that. And for them, it's okay. They can adapt to 3 degrees. For the rest of the world, well, too bad for them, right? They will migrate. I mean, migration is seen as adaptation for the poor world. Anyway, so I think the key word actually was adaptation. And it remains adaptation. For the second question, which was
technocrats from the 20s.
Yeah, the technocrats. So it's a different topic. But I was really fascinated by this group of people. At one point, after the economic crisis in 1929, there is really some serious reflection about rebooting capitalism. That doesn't work. It is irrational. We've got poverty and overproduction. How come that you've got pauperism, people dying, suffering from hunger, and overproduction elsewhere? So we have to reorganize the economy on completely different grounds, and this ground will be energy. Energy is the true yardstick for valuing the goods. Money is it's a rubber yardstick. They say it's too flexible. There are inflation and there are a lot of problems. Let's go back to what is really important, energy. And the technocratic movement in the US, which really became a mass movement. At one point, there are 250,000 people were registered as technocrats. And the technocrats, they wanted to set up a new monetary system based on energy. The point was that we know the amount of energy that we put into the productive system, and we're just going to monetize this amount of energy certificates. So in that case, we create the equilibrium between production and demand. And then there were techno-optimists for one technology, which was hydraulic energy. The technocrats, their big problem was basically exhaustion of coal and oil. This is the real national treasure of the US. And we have to preserve this treasure whatever it takes. And to do that, we have to maximize the use of hydroelectricity instead of coal. And to do that, we need to annex Canada. And the funny thing is that one of the grandfather, I think, of Elon Musk was one of the technocrats of the 1930s. Anyway, so there is this idea that they would create a North American technate from Mexico to Canada, which would optimize the management of energy on a continental scale. These technocratic movements, they had some very nice ideas, like it's a very egalitarian. They think that people should be entitled to a certain amount of energy certificates, whatever they do, even if they are jobless and so on. So there is this dimension. They are against conspicuous consumption, and Thorstein Veblen is one famous Norwegian-American sociologist, was one of their inspiration. But they also ended up close to a kind of a chief cult, how do you say? The founding character of the movement called Howard Scott had a kind of dictator dream in a way. So he was also very opposed to the US involvement in World War II. So he was discredited for all these reasons.
Right. Well, maybe you should I go one more question before opening the floor? Well, still on this transition as the ideology of capital, which you mentioned in your book, you also have this sentence which goes something along the lines that overcoming capitalism might be a necessary but not sufficient step for whatever the right direction is. And then you mentioned that the IPCC mentions ban 3 times and just notes that, well, it's unpopular. Sure. So I guess the one question on the top of many people's minds is then political feasibility. Mm-hmm. So that how does this translate into a democratic process or whatever? Because you said that we need to have a democratic discussion on this, like priorities. There's some research and some people argue, theorists of democracy and democratic politics, that democracy was built on mass consumption and it's simply not capable of doing this kind of thing. What do you think of this and say about the political feasibility aspect?
I am quite pessimistic also on the political feasibility of serious degrowth. But I mean, once again, perhaps what is feasible is decreasing, but getting to zero is probably impossible. But the sooner we understand that zero is impossible, the better. And because we will have this discussion on, okay, so where do we want to invest our CO2 on that, for which kind of needs? And I think I'm pessimistic about the net zero, but I do believe that a more democratic discussion will be much less based on false technological promises. And we've got one example of that coming from France. After the Yellow Vest movement, the government set up a kind of citizen assembly where random citizens, which were really chosen by randomized procedure, were chosen. And then they spent a few weeks just learning about, the science, basically. And they ended up with a very interesting proposal. This proposal would not get us to net zero, but at least they were going in the right direction. First of all, no more advertisement for particularly polluting stuff like automobile, travel, faraway countries, and so on and so forth. So just starting to work on advertisement, which is a very powerful force to shape desires, social desires, right? So this was one proposal, interesting one. Immediate limitation of speed on the highways. I mean, that doesn't change the life of anyone. It actually saves lives, and it saves CO2. And there was the third one, which was interesting, and I forgot. But anyway, and they were not talking about hydrogen, and they were not talking about negative emissions. They were talking about serious stuff, really concrete stuff that we can do right now. So I think a more democratic discussion, which actually would allow for much more grounded solutions, much more realistic solutions. So, I mean, in many corners of the debate on climate change, there is this idea that the problem is the people. There are some enlightened experts, but the real problem is the people that are kind of stupid or selfish and they vote, so it's terrible. I think it's really the wrong premise. I mean, it's on the contrary. It's rather the solution have to come from the base, not from the crazy dreams of modelers.
Thank you. Unless you have something absolutely burning to add, maybe you could open the floor and take some questions from the audience. Tony will bring you the mic and ask you to speak into it.
Is it on? Yes, it is. Keep it close. Short questions. Let's take you three here, and then Jean-Baptiste has the turn.
Hey, yeah, just wanted to maybe be a bit more optimistic about some processes, like, for example, the European Union, we have had our emissions going down, and also, it's not just been, outsourcing the emissions either, in general, there's, dozens of countries where there's, both, consumption-based emissions also going down with, economy growing. So I think there are, positive, I don't think it's just additivity. So there are these actual transformations that give hope that it can be done globally.
No, you are entirely right. In many countries, emissions are decreasing, even taking into account imports. That is sure. And because there is technological progress, right? I mean, there are improvements in all sorts of industrial processes. But I think there is a big difference between reducing emissions and getting to zero. An enormous difference. And the problem with climate change is that it is cumulative. So, as you said, I mean, there's reduction in emission even at the European scale and so on, but that just delays the problem. It doesn't solve it, right? So I think it's not that I see I don't know if this actually an English expression, you can see the glass half empty or half full. So it's not that I'm just seeing the glass half empty, it's rather that I see the tap half closed. And water and climate change will happen, even if we reduce emissions to 1/3, 1/2, which is possible. I mean, we have the technological means to reduce global emissions by half, I think, because we can electrify transport, I mean, like motor cars. We can produce almost zero CO2 electricity and so on. But with all that, basically, you divide by half the emissions. We just delay the 2-degree and then the 3-degree to later in the 21st century or later in the 22nd century, but it doesn't stop it, right?
Hi, thank you very much. I'm a sufficiency researcher, so sobriété in French. So in historical terms, I would like to ask you if there are any cases of something that could look like something like sufficiency in a history, or is it something that was not maybe studied? And if there were some cases, how could those offer leverage points to think today?
Okay, just as on energy transition, history is not a great guide for the future. The very few examples we have of really sudden and massive reduction in material demand, it's when there are crises. So it's wars, where you've got sudden decrease in all sorts of consumption. You have some, I mean, you could say that the case of rationing in Britain and the US during World War II could be used as a kind of positive example, because in Britain and in the US it is seen as kind of patriotic. You know, they tightened their belts, but it was for the greater good of winning World War II and free the world. But I don't really buy this kind of interpretation for one simple reason. People knew very well that it was short term. And when you look at the propaganda and rationing, justifying rationing in the US, it is always connected with a dream of future abundance. Let's make an effort now, and later we will benefit from all the fantastical technologies that are emerging because of the war, right? So I don't think we have, you know, like kind of useful examples from the past to reflect on these kind of problems. The case of Britain is interesting about food. There is a fantastic book by Lizzie Collingham on food and war. And she said that actually health for the lower class in Britain improved thanks to rationing. Because rationing actually was based on what was the minimal requirements. And that would allow poor people to buy some simple vegetables like carrots, leeks, and potatoes. But it was better than what they had before. So here you got rationing and a kind of improvement for people with less money. There are some other examples which have been used by different scholars, like the fall of the USSR created really an economic catastrophe for two dependent countries, Cuba and North Korea. And for the case of North Korea, it was really a disaster, like there were famine, I mean, really a terrible situation. The case of Cuba was better managed. It's called El Periodo Especial. And they really transformed their economy to cope with the lack of oil, basically cheap oil coming from USSR. But nevertheless, I think they lost on average 5 kilos per person between 1992 and 2002, and then they got cheap oil from Venezuela, right? But I don't think it is any kind of hopeful historical precedent, right?
Bonjour, merci beaucoup pour l'excellente présentation. My question goes actually into that topic of rationing and oil. You mentioned the oil shocks of the 70s. Which were a huge deal, and rationing and all of that. Why is it that we are now in the middle of a much bigger oil shock due to the Iran war, and yet the urgency and the magnitude of it doesn't seem to have arrived in people's minds?
That's a really great question and a great mystery for me, actually. Yeah, it is surprising. I mean, honestly, it is surprising because you got Fatih Birol saying this is the biggest energy crisis of all time, much bigger than 73, much bigger than 79. And it is true when you look at the data on 73 and 79, actually the drop in terms of global consumption was very small. I think it's 5% in 79 just for 1 year, right? It was really, really small. But the price rise was enormous. So what really matters for people is price. I guess in the rich world, it's price and not quantity. And for the moment, traders, they don't bet on like a long war. For the moment, the crisis has been buffered by strategic reserves, which have been decreased a lot to cope with the growing scarcity of oil and gas. But you're right. I mean, we should be much more concerned about that. Yes, yes. I think the biggest concern is about fertilizer and food in Asia. Basically, and here we've got some historical precedents. I mean, in 2008, the price of oil and gas and fertilizer skyrocketed, and that created food problems in many countries, in Egypt in particular, in many other countries. So I think we should be concerned about all that, yes, indeed. And we should, for instance, and it's not an argument to say that we should extract fossil fuels, but like gas is vital for nitrogen fertilizer. But nitrogen fertilizer is just like 5 or 6% of natural gas consumption. So it is totally possible to just sanctuarize this 5 or 6% to be sure that it is provided to fertilizer factories so that peasants in the poor world will have the fertilizer they need. I mean, it is totally doable. If ever there is like and I hope there won't be the food crisis in 27 or 28, it would really be because of poor management of the situation, because it is really something which is preventable. And basically other countries can reduce their gas consumption for electricity production. European countries have done that in 2022 after the invasion of Ukraine, and basically it was not a catastrophe. I mean, it was totally possible. But you're right, it should be really on the top of the international agenda, and it is surprising it isn't, yeah.
Thank you for your talk. I want to pick up on two of your quotes. So you said that because of modelers, we did not have a certain discussion. And you also said that transition studies are sexy. So I want to ask you that, is there a coevolution of power structures and storytelling in academia?
My answer is yes. I mean, we should not think that all this knowledge is just pure and disinterested knowledge. For the case of, at one point I show how much discussion in the IPCC report there was on, novelty and innovation and so on. I think it's because basically in academia we are supposed to work at the technological frontier. So if you ask engineers or scientific departments to find solution and talk about solution to climate change, of course they will talk about the scientific frontier and the technological frontier, because it's what they are paid for. So there is a structural bias in academia to talk about that. And then there is also money. For carbon capture and storage, carbon capture is not, for chemists, it's not very interesting. It's not like the subject that naturally chemists would study. But if you got an academic system where you're incentivized for your career to get money from the private sector, of course there will be a lot of papers on carbon capture, even if it's not that interesting in terms of science, right? So we should remember that there is this structural bias in all the mitigation expertise, that it is geared to talking about new technology, and by definition it's going to be about that. So the IPCC report is just reflecting this structural bias in a way. In the last report of 2022, it is striking to see that fashionable technologies that were discussed in the newspaper just before the report are overwhelmingly represented. For instance, there is a lot of discussion about blockchain. Blockchain as a fantastic tool for booking an electric bicycle. Why is that present in the report? It shouldn't figure in the report, shouldn't be in the report. And there is even a discussion of the Hyperloop. Elon Musk's crazy idea of trains circulating at 1,000 kilometers per hour in vacuum tube. They describe that as an emerging technology. Right? It is really slowly emerging, right? So yeah, there is really serious problem about the mitigation expertise. Why? Because it is very applied science. And applied science is closely interconnected with industrial propaganda. In the last report, there is a lot of blah blah about smart cities, smart industry, smart agriculture. Everything is becoming smart. You know? There's a lot of blah blah about the fourth industrial revolution. The fourth industrial revolution, personally, I don't know what is the first, the second, and the third. I'm not sure it doesn't make sense, actually, to talk about industrial revolutions. But what I want to say is that there is a very strong porosity between the corporate discourse and mitigation expertise. And this is an issue. Yeah.
We're soon running out of time, so we probably have one more question.
Oh, the pressure. Hope this is a good one. My question has to do with the response of the book. It's such a great book, and I know well, everybody I know who has read it has been influenced somehow, and I know of one manuscript that has kind of been thrown out because of the convincing argument. So the question is, given that people are so kind of attached to, or some people might be so attached to the idea of transition to withhold their kind of career. Has there been some like pushback? There was a mention about the global and local kind of pushback, but has there been another kind of big pushback from people whose kind of careers depend on thinking about the transition?
Yeah, I think there are two pushbacks. One is by people, not so much in academia, but like people who are involved in clean energy and all this stuff. They saw it as a critique of renewables, which it isn't at all, honestly. On the contrary, I mean, it's actually quite in favor of, it's the only sector where we've got some good news, it's clean electricity. But basically, they are selling solar panels, they are not saving the planet. Right? I think we should be able to differentiate between selling solar panel and saving the planet. They're not exactly the same job. And there is another pushback from, especially in the US, people like center-left, neo-Keynesians, people involved in the Joe Biden Inflation Reduction Act. And I think it's because in the US, the situation is so desperate that they can't tell the truth, basically. And they prefer to have this kind of discourse to convince the Americans that it's not an issue of making efforts. It's with renewable technology, it's about catching up China. So they create China as this kind of technological utopia with super advanced technologies in all sorts of green technologies. And so the transition card is actually a China card in the US debates. So this is the other pushback. People who think that you cannot sell to the American public any kind of discussion around the reduction of consumption. And I understand what they are doing, basically. I mean, it's perfectly legitimate. But what they are doing is imagining the right program for the Democratic Party to win the election, which is not the same thing as reflecting seriously upon climate change. But so this is another important pushback from the democratic thinkers of the US. Yeah.
Thank you. Thank you for the questions. Thank you, Jean-Baptiste, for this
wonderful talk.
Thank you so much
for making that possible. Thanks a lot.
I remind you, we have some refreshments there, back where Tony is waving his hands. We hope that many of you can join us. And once more, Jean-Baptiste Fressoz.